Okay, so we're just going to do a basic control setup, what the control is used for, what everything means, and then basic operation of the machine. Okay, so firstly, let's run through the controls. We're going to start on top. Set arc voltage is the voltage that you set your machine to. It just shows you the voltage there, what your pierce time set, and what your IHS uptime is set. Actual arc will display once you start cutting. It just shows the difference between what you set and what the machine actually uses to cut with. Then IHS check time is just your initial height sensing, checking how long you gave it to do that. Then arc time, how long you gave it to try and make an arc before it gives you an alarm. Pierce time is just how long it pierces, obviously, and then it will go torch up, torch down. Every time your torch moves up, moves and goes down again. And then lock THC is your torch height control. It just means that your torch height control is now active. And arc feedback means you're getting arc feedback so that your torch height control will stay active. If that does not work, if it does not activate while you're cutting, it means that something is wrong. Okay, so then from there, auto THC is auto torch height control. If I press 0, it will go to manual. Now my torch height control won't work. So if you cut and you find your torch height control is not responding, one of the first things you can check is whether that is on manual or on auto, because it's easy to just press a 0. Okay, then cut speed, it just shows you the speed that you're cutting with right now. Your curve should be set to 0 because of your drawings. And then Y, your manual speed movement, 6000 is just when I press the buttons, how fast the machine is moving. And then F, manual keep move. So if I press F, I will go to step move. That just means if I press the button on the machine, it will move in steps. If I go again onto F and I press it, it will continuously move automatically without me having to hold the button all the time. Okay, and then I'm going to go back to keep move, where I actually have to hold the button in for it to move. Okay, step distance is 5. So that means basically 5 millimeters for every step is 5 millimeters or 5 microns as it works out. So that is just your distance of your step. You can also check, let's say you cut out of size. You cut 100 by 100 square and it comes out smaller or bigger or whatever. You can check your step distance and it should say another number there. Then you know you have to go into your control settings and then change that. Okay, so then X and Y axis is just the axis that you move on, the distances that you move on your two axes. Okay, now we're going to start. The whole control basically works from left to right, F1 to F8. So the first thing we want to do is we want to get a 0 point on our machine. So I'm going to move my torch manually to come to the side of the plate here. So I'm going to go left, page down to let it go lower, come back. So the edge of the plate will now be in the center of my nozzle like this. Then I will say F8 0 and I know I've got a 0 axis. Now the machine knows that is my 0 point. Whenever something happens and I tell it to go back to 0, it will automatically move back to that point there. Okay, so we're going to start with F1, shape library. There is 53, if I remember correctly, 54 preset shapes on the machine. So what you can do then is you can just go down and choose whatever desired shape. Let's say you want to make a foot plate or adapter plate or whatever, flanges. You can go up to there. Then lead in and lead out. Lead in is basically, if it wants to cut, here's your circle. Not to start your pierce on your cut. Then you're going to have an ugly pierce mark there. So it starts before and it cuts into your shape and then go past again to cut out of your shape. Okay, so lead in. Now it's set on 5 millimeter. Depending on the thickness of your plate and the size of your hole, you're going to set your lead in. Lead out, the exact same thing now, it moves past. So you can move, make your lead out. I usually make it as small as possible or even 0. Just plainly because if you're cutting a smaller hole and then you have a lead out of, let's say, 5 millimeter, your plasma torch will come to here, that small hole will fall away. You won't receive any feedback from your torch will go down and give you a plasma collision. So I normally make my lead out either as small as possible or 0, just to spare you that frustration. Okay, then size 1 shows the outer diameter of my circle. Right now it's set to 100. Size 2 is the diameter of your bolt holes, the inside holes. Right now it's set to 24. Size 3 will be your center points between the two holes, your PCD. So right now it's set to 60, and then quantity 5, now it's got 5 holes. If I want 4 holes, I just say 4, and it will space out the 4 holes automatically. Okay, so then after you've chosen your shape and you've set all your parameters, you just say enter. Okay, second thing, files. Files is just the difference between the shape library and the things you draw. So now I've drawn some things on my computer, I've nested it, so I'm going to go to UDisk. I'm going to choose something that I have then drawn. Let's see, I'm going to take that first one. And then from there it works exactly the same as it would of your shape library, because you've already drawn the part, gave it all its sizes, so you don't have to set all that. Yeah. Then from there, F3, part option. So we're going to go back to F1, starting point. So the machine itself will always be left bottom. Left bottom will be your default starting point here, except if you cut circles. Mostly if you cut circles, your starting point will be default in the center. Now my torch is on the left side bottom of my plate, so I'm good with that, but I'm just going to show. Let's say for instance my torch was up there now. I'm going to say starting point, and I'm going to say on my plate I was right and top, so F5. Let me just press F5 there, and it will automatically move there. So my machine knows now it must go left and down. Okay, right now I'm left bottom, so I'm going to go back to F2, left and bottom, so it knows it must go right and up. Okay, then secondly, angle. Angle is just like now, I've just thrown a piece of plate on, I don't want to square it, I just want to cut something quickly. I can tell my machine that my plate is actually skew. So what I'll do now is I'll go F1, steel plate adjust. Okay, so because I've already got a 0 point there, it says here X to start and Y to OK. So I'm going to press X to start. Then you move your machine manually, like that, and I'm going to bring it up to the plate so that the center of my nozzle is again on the side of the plate, exactly like it was here. Now I'm done, so I'm going to say Y for OK. I say Y. It's going to ask me, do you want to return? Obviously I want to return to my 0 point, so I say enter, and then it will know how skew my plate is. If you look here, the drawing is now slightly slanted, so that the machine knows now it must cut skew so your parts come out straight, basically. Okay, so from there we go array. Array just means, let's say I want to cut 10 of these parts. You get 2 types of arrangements. It's straight and stagger. So I want to see on my piece of plate I can fit 4 of them next to each other, so I'm going to have to go 3 on top of each other because I want 10 of them. So what's going to happen now? Square things, you go straight, it's next to each other and on top of each other. Round things you will go stagger, because what it does then is it creates that little zigzag on your circle, so you don't have wastage of your plate. My drawing is square, so I'm going to say F1 for straight. I'm going to tell it that I want 3 rows and I want 2 columns. Like that, and it will nest it. Okay, so now automatically it will cut out those 9 for me. Okay, so that is basically what you're going to do in this menu. The rest is not anything to worry about. You're never going to use that. That's the 3 main things. So after you are done, you're going to go OK and OK. So now it will remember exactly everything you did. Okay, from there we're going to go F4 setup. Setup, we go back to F1 again. Always start from left to right, so we're going to go back to F1 again. So the first thing you're going to do here is you're going to look at your cutting speed. Your cutting speed, your pierce time, and your voltage, your set arc voltage, is always going to be adjusted according to the thickness of the plate that you are working on. Different plasma sources obviously uses different settings. So the plate that I've got on here now is a 1.6 millimeter plate, so I can cut that, let's say, at 1800 speed. 0.00. Okay, so next in line is just manual move speed, is the speed that it moves when you move your arrows manually. GOO move speed is just the speed that, let's say I would tell it, go back to your 0 point or move to the other side of the machine, how fast it's moving. Demo and back speed is just if you run a demo or your cut goes bad, you stop it and you want to go back, how fast it moves. Marker speed, you don't have to worry about, this machine doesn't have marking. Curve value is the value that you have, the width of your cut. How much space must it make up for the width of your cut between two parts when you are cutting? Sorry for that. And yeah, so that's curve value. Right now it's set to 0 because I'm running off a drawing. The drawing was on my computer, I already set curve there. Okay, cornering speed. Cornering speed is just when it goes around the corner, how fast it goes. If it goes too fast around the corner, you're going to lose your cut. So it's going to cut nicely, and as soon as it goes around the corner, it's going to start running away from your cut and it's not going to cut anymore. So then you slow it down a little bit. I dropped it down to 90%. If you make it too slow, it starts making your corners round. So you have to get it so that it's slow enough to go around the corner, but not too slow so that it rounds your corners. Then you're not going to have a square part anymore. Yeah. So then demo run speed is just when I run a demo here at the shop. You're not going to worry about that. My cutting type is plasma. Obviously I'm running it on a plasma machine. And my starting point, I put it on default. Default will be left bottom, and on a round thing it will be center. You can change that if you want to, but you can put it center, left bottom, left top or right bottom. I just left it default. It's just the easiest. Okay, so from there you see flame. We're not going to use flame. This machine doesn't have flame cutting, so we're going to pass that. We're going to go to plasma. Plasma, delay before arc. We're going to start running from the top. It's just the machine goes down, it senses the plate, comes back up. How long must it take before it starts cutting? On the bridged machine, you don't need a delay before arc because your machine is quite stable. On the entry level machines, which is a swing arm machine, we normally like to put a little bit delay before arc just so the machine can stabilize and stop bouncing before it starts cutting. Okay, then pierce time. Pierce time is the second thing you're gonna set on your cut. It just basically means that how long must it pierce before it starts cutting. If you don't pierce long enough, then obviously it doesn't pierce through your plate, so you won't be able to make your cut. If you pierce too long, it's going to burn away too much material. So you're going to get a pierce, and then as soon as you start cutting, your nose is going to dive, and you're going to get a plasma collision. When that happens, you know your pierce time is too long. It burned away too much material, so your arc feedback doesn't pick up material. You can make your pierce time lower. Right now, 1.6 millimeter plate, I'm going to drop my pierce time to 0.2 seconds. Okay. So now we're going to move down, torch up time, arc check time, and IHS check time is what I explained on the main screen. Now it's just how long time you give the machine to actually try and do something before it gives you an error that it can't do it. Then IHS uptime, initial height sensing uptime. What happens, your nozzle goes down, it senses the plate, it comes back a certain amount, and then it starts piercing. That is the certain amount. So on the thinner plates, you keep it low. You should, like now, 0.3 seconds. So that it's close enough to your plate that after it pierced, it doesn't need to dive down far. So that I had to start cutting, then normally you're going to get a plasma collision. And also the higher your torch is from your plate, the bigger your hole is that you're going to burn when you pierce. So you set that according to thicknesses of plate, but we found that on anything from 1 millimeter plate to about 8 millimeters of plate, you can keep the same as one setting, and then above that you can go a little bit higher. The reason for going higher on the thicker plate, when you go down and you start piercing, you get a lot of blowback. Blowback burns your nozzle. So what you will do then, if you do the thicker plate, you're going to lift it a little bit higher, let's say 0.45 seconds or 0.5 seconds, so that it lifts up higher, pierces through so that the blowback that comes up doesn't burn your nozzle, and then after that it will go down and start cutting according to your torch height control. Okay. The rest of the settings here is just basically the torch moving up and down between cuts, how high it must lift to go to the next cut, go down, and then how fast it must move while doing that. Okay, so then the next thing you're going to watch, your watch arc enable. It should always be on. If you switch that off, your torch height control is not going to work. After that, you look at your set arc voltage. Okay, set arc voltage is basically you telling the machine how much voltage feedback it must have while cutting. So the torch height control unit works on voltage feedback. So you will go down, start cutting. The machine will sense a certain amount of feedback from your plate. If your plate starts whopping, it goes skew, your torch will go up with that plate. So the higher you make your set arc voltage, the higher your nozzle will be from your plate. Lower, obviously, the closer your nozzle will come to your plate. You want about 2 to 3 millimeter between the nozzle and the plate is a good cutting distance. So when you are cutting and you find your nozzle is high, let's say 5 millimeters, 6 millimeters from your plate, you're going to lower your set arc voltage. If you find it's scraping on the plate or it wants to touch the plate all the time, you're going to lift your set arc voltage. So all that now basically to tell you to set 3 things. Firstly, you go to common, you're going to set your maximum cutting speed. You're going to go to plasma, you're going to set your pierce time, and then you're going to set your arc voltage. Okay, after that you go save and you confirm again with save. Okay, I'm just going to go and choose one drawing now. I don't want to do 6. Okay, so all my settings are done. I've chosen my shape. I went through my files. I've done all my part options. I've told the machine I'm skew. I have done how many multiplications I want. I've checked my starting point. I went to setup. I checked my speed. I did my pierce time and I did my voltage. So basically now I can start cutting. So my torch is ready there. I'm just going to tell it to start and enter. Okay, so this was the part I cut here. Okay, so basically what the screen said there, I just waited for the air to go down. After you made a cut and it finished cutting, it's always going to ask you, do you want to finish your cut or do you want to continue? So you're always going to say enter to move back to your 0 point. Okay. So a couple of things we have to look at now while we cut. The time we were cutting, let's say you find your nozzle is a bit high while you are cutting. In your cutting frame, you have back, demo frame, speed down, speed up, reduce arc and add arc. Okay, so what happens now is, let's say it's busy cutting and I find my nozzle is high. I don't have to stop my cut, go back to my settings, go change my settings and come back to my cut. I can add arc and reduce arc while cutting. So if my nozzle is high, I can say reduce arc so my nozzle goes down to my plate. If I find it scraping, obviously you can add arc and your nozzle will lift up. Same with your speed. Let's say I'm cutting, I find that it looks like it wants to run away from the cut. It's making a lot of sparks on top of the plate. I want to slow down my cut so I can get a better quality cut. You can just say speed down. If you are cutting too slow and you find there's no sparks on the plate, obviously you're wasting time. You want to do it as fast as possible but as nice as possible. So then what you can do is you can go speed up until you find sparks starting to form on top of the plate. Then you know your speed is good. So you can go speed down, speed up while you are busy. I'm just going to run a quick demo here just to show you. Let's say now it's busy cutting. Now let's say something wrong happened now. It started to run away from my cut. It didn't cut nicely through my plate. What I can do is I stop it. You can go back with your back button and stop it again up to the last point where it was cutting good. And then I can say start again and it will cut through. Let's say now I have a place on my nesting. I want this part here and that part there. What I can do then is I finish cutting this part. When it wants to go to the parts in between, I can run a demo. So the machine will basically run as if it was cutting up to the point where I want to cut again. So I will stop the demo there and I will just say start and the machine will go down and start cutting there. That's basically what the demo and back is for. Okay, so when I'm done, something happened, I want to go back to my 0 point, I can tell it to go back and it will automatically move back to my 0 point. Then the next thing. Okay, so now let's say I'm busy cutting and then good old Eskom comes. Okay, power goes out while you are busy in a cut. Now you're halfway in your plate. So, which means you are potentially losing half your plate because now halfway of your cut, the power went out. So what you can do, remember this machine can move manually by hand when it's off. Don't move it, just leave everything as is. Power comes back on. Normal machine startup. So what you will do now, you see F7 says manual move. Say F7 and then F7 again says recover. So I will recover. My machine will remember exactly where I was cutting the time the power went off. I can just say start and it will continue cutting. Okay, so that is basically the movement and the working of the control and then the operation of the machine. If you hear that,